Hi, everyone.
Hi, everybody. Let's talk about one of the hardest parts of designing a spoken dialogue between a human and a computer.
How to handle so-called errors.
Now, before we dive in, any good conversation starts by knowing who's talking. I'm Nandini Stalker.
And I'm Leon Nichols.
Leon is a developer relations engineer for Google Assistant apps.
And Nandini leads the conversation design outreach for Actions on Google.
Our two teams are responsible for most of the resources that you'll find on the Actions on Google public website, where we show developers how they can design, build, and deploy their apps for the Google Assistant.
Now, you can implement the techniques we'll show you today using tools like API AI through fulfillment logic in your code, or as a combination of those. By the way, API AI is a tool for creating apps for the Google Assistant. Now, we want to help developers create great conversational experiences. The best way to do that is by considering the design first, and working in tight collaboration between designers and developers, iterate on that design within the capabilities of the platform.
Now, in human-to-human conversations, hesitations and corrections happen all the time. We just did a little bit of it ourselves.
Right.
We might do it again, and we'll just blame it on the talk.
Now, in human-to-computer interactions, they do too, but in the form of timeouts and recognition errors.
The difference is that humans can take cues from each other to get back on track in real time.
But with a simulated conversation, the corrections need to be pre-planned, and that's not an easy task.
So the only way to course correct in advance and still maintain a natural, comfortable dialogue is to plan for them as if they were any other turn in the conversation.
Now, here are some of the terms we use when talking about errors in voice interfaces.
One of the first things to remember is that there's a difference between the technical conditions and events that trigger and respond to these errors, and all the user scenarios that are happening at the same time. So any number of things could go wrong from the user's perspective, so for any number of reasons.
Now, we'll show you how keeping both of these perspectives in mind will be really key to your conversation repair strategy.
Otherwise, it's pretty easy to become either too simplistic or with a basic strategy of just apologizing and asking the same question over and over again, or being overly prescriptive and formulaic in your approach.
Now, for example, here's a formula that's really common and often built into a lot of tools and defaults.
But this often translates, unfortunately, into a user having to be asked effectively for the same piece of information with very little variation, 3, 4, 5, or even 6 times.
So that leads to a really stiff experience, but also a very frustrating one for users.
It's important to note also that user impressions on how they're formed in that moment when they're going through an error is not just about the interaction itself that they're going through. It frames how people feel as a whole about the technology, something that we really care about changing. So in fact, we've asked people how they feel when recognition doesn't work, and they have negative, visceral reactions, and they can't always place why. So one of the reasons is because people are using their voice. Voice is one of the primary markers of our identity. And so it feels extra personal when something goes wrong. So let's dive in and see how we can handle these with a new paradigm.
So we're going to show you how to so-called error events could be handled and not treated as edge cases.
So instead, we're going to leverage users' innate expectations about how natural conversations are supposed to work and create opportunities for more meaningful interactions.
So that means for any given prompt to your user, you have to be thinking of all the things that could go wrong in that moment.
But you can still break it down into 2 paths to the problem. Either you didn't get any input, and usually that's because the user didn't say anything or because they were too quiet to be picked up by the mic. So Or it could be that you got input, but you just weren't prepared to handle it.
In the underlying system, these two categories can be addressed as either no inputs or no matches.
But as part of this new paradigm, we're not going to start there. It pays to look at how you can eliminate the bulk of your errors right off the top with some preventative strategies. Now, first of all, you want to use the power of spoken language to your advantage by using well-crafted, intuitive language in your prompt structure and prevent errors in the first place. So there's a great talk tomorrow about this by the godfather of voice user interface design, James Jangola. Must not miss.
Otherwise, look at how you can prevent errors by being prepared to handle specific types of requests, but with more robust strategies.
All right. So your first preventative strategy, be ready to provide help in the moment. So this usually means being ready to handle if someone asks to hear something again, or they express their confusion maybe more explicitly by saying something like, I'm not sure, or why do you want to know? So let's look at how we implement that.
So we need to be able to first categorize these responses and then add logic to handle them. Some of the main concepts in API AI include agents, which can be described as natural language understanding modules for apps. Agents consist of intents, which respond to particular user inputs, and contexts, which are the ways to prioritize those intents as they are invoked during a conversation.
So during the many back and forth turns in your conversation, each of the user responses will map to an intent. So like you see here, a few key ones are repeat, help, and quit.
So here's a help intent we created in API.ai.
Notice how it's not just a global command help. That's not the only thing we're handling. All the things the user might say to ask for help. How you respond to those, of course, will depend on your strategy, and we'll show you a little bit about that. But perhaps you'll give them a hint, or you might ask them a follow-up question to make sure they're ready to continue.
To make that work, we have to add additional intents for the user's yes/no responses to that help prompt, like you see here.
So, OK, next, immediately, I want to jump in and find out, how do I make it even more relevant in that moment? Maybe by playing some dynamic data, like if I want to include a variable, for example.
Sure. So you can do that using fulfillment.
So great. So as you can see in this example, some dynamic info about the game length ends the question with asking if the user wants to continue. So now they're actually listening for a yes/no answer to the help question itself.
Yes. And we can dynamically set a context to ensure that the user's yes/no response is handled by the yes/no help intent.
But, so if the user got the help they needed when they heard that, and they didn't say yes or no, but they just answered the original question before they asked for help. So we wouldn't want that to trigger an error. Otherwise, we sort of defeated the purpose to begin with.
Yeah, right. So we don't have to worry about that since the other game intents are still available, and we'll handle it if that happens.
OK, so that's help, and some of the questions that come up in the moment, like repeat. So it's a pretty big prevention strategy out of the way. Another very basic strategy is to prevent frustrating back and forth is to simply make it easy for users to leave. So they might need to stop for a variety of reasons. So being prepared for that is not only key to preventing errors, but it's the right thing to do.
Also, it can be an opportunity for re-engagement. For example, perhaps let them know how to come back, or pick up where they left off, if that's an option, but without being annoying.
So for this, we need to create another intent for quit, right?
Yep. So start by anticipating all the ways the user might want to leave. So just like help, which phrases you might choose depend on the context.
So for this game example, here you can see we've added some custom phrases that are appropriate for a game, like stop the game or stop playing. And just like help, we want to make the response to user more meaningful. And since it is a game, I want to give them the satisfaction of knowing their score, where they've left off.
Yeah, so like we showed you with help, if you want to include a variable, that's where fulfillment comes in. And so here you can see our quit intent, and we're giving the user the score before saying goodbye.
So to give you an idea just how these prevention strategies are so critical to catching things in context and why that matters so much is take a couple user responses that really mean something different depending on the situation. Take, for example, I don't know and I give up. So in most contexts, I don't know means it's just another way of saying help. But if you're playing a game, and that may or may not hold true. So for example, on the one hand, you could have a game where the user maybe wants to know a little more about the rules, and they're not familiar with it. So in that case, sure, I don't know means help, like any other context. But if it's a familiar mental model, like guessing game or trivia, where the user says, I don't know or I give up, it might just mean they want the answer so they can move on. So in which case, it's literally the opposite of quit. It means let's keep playing.
Now, this might mean breaking up your help or I don't know phrases into different contexts. Take two games we've been working on. In our number guessing game, Number Genie, here on the left, I give up is part of the quit intent. But with the trivia game on the right, I give up is part of the I don't know intent. This lets the user skip giving an answer to the question.
All right, so another way that, to prevent errors is to use the built-in capabilities of the platform. So we've just announced several of these at I/O.
So our tools and libraries support common interactions called conversation helpers. Now, these have been crafted to follow best design practices and also to handle errors. So we recommend that you use these so you don't have to create them for yourself.
All right, so that's a lot of deceptively simple but often overlooked error prevention strategies. Those should help your users feel more in control of the interaction overall. Now, let's get to the unavoidable stuff.
So as we said earlier, even in conversations between humans, hesitations and repair happen. And as we know, speech recognition isn't perfect. So when it doesn't work, let's call those errors for now.
So we've got a couple great strategies coming up where they'll make them feel a little less like errors per se and more like new turns in the dialogue, like we've been promising. But before we show you that, we think it is important to see what it looks like when you do start from scratch.
We'll look at our basic errors, the no inputs and no matches. If you create a new agent in API.ai, you get two default intents as a starting point. The agent will start by greeting you with the default welcome intent. And if you don't say anything, it'll hit a couple of no inputs and give up. If you do respond, you'll hit a no match.
So you're saying that starting from scratch, we have a clean slate of only errors.
Yeah. So let's take a look at how the default agent handles no inputs. We're going to play a video of me invoking the agent on the Google Home and not saying anything.
Version of default action.
Hi. I couldn't hear what you just said. Hi. I couldn't hear what you just said. Hi. Sorry, I can't help.
And for no matches?
For no matches, well, that'll invoke the default fallback intent, which has a set of static responses that are selected randomly to respond to the user.
So anything the user says will go to the default fallback intent. So let's take a look at that.
OK, let's do that. So we have another video, and that's also invoking the agent.
Talk to default action.
Sure, here is the test version of default action.
Hello.
Hi.
I missed what you said. Say it again.
I said hi.
Sorry, could you say that again? I didn't get that.
I'm trying to greet you.
Can you say that again? What was that?
I said hi.
I didn't get that. Can you say it again? What was that?
Why do I have to repeat myself?
Sorry, what was that?
Okay, goodbye.
Okay, so as you see, the conversation never ends. And if you want to change that, you have to add a custom intent to handle the first user response.
Obviously, that's no way to hold a conversation, and we do have a lot of built-ins that you can add, but it's important to start from that just to see how it works if you were to start from scratch, so that all the things that we show you next will make sense and connect.
Otherwise, API AI does provide some sample data and pre-built agents for common use cases that you could start with instead. And we're always looking at ways to improve the tools better by default.
So in the meantime, we'll use that as a baseline and explore some more targeted solutions.
OK. Now, let's take the case of when no input is triggered.
So here, remember that the user either actually didn't say anything, or perhaps they got distracted, or they didn't hear the question. Maybe they were listening, they didn't understand it, and they were just waiting to hear what it would do next. But it could also be that they started talking during the prompt and then stopped talking right when the mic started listening.
So how do we design for that?
Well, for no inputs, you probably need to consider first if you even need the answer to get to the next step. So how you react should really consider why the user didn't respond, all those reasons I talked about. So it's a new turn in the dialogue, therefore an opportunity.
Now, we have some examples that show the difference it makes to your wording, depending on how hard you want to try and how much help you assume the user needs.
So when you write reprompts for no input, you should keep them contextual, but that doesn't necessarily mean repeating the exact same question verbatim. So maybe you just need to reframe it or reword it just slightly. Or maybe you could use it as an opportunity to answer an unasked question. And as for how many times you want to try, maybe you don't want to belabor it, and maybe you just want to gracefully exit. But for most cases, you could make use of some sort of default pattern. Right now, the default is 3, but maybe it might change. And find out, just specify what you want it to say for each of those 3. So that's a design strategy for no inputs. Let's take a look at how to implement it.
OK, so as I mentioned earlier, the default API AI, by default, API AI handles the no inputs for you by using a list of standard prompts. Now, to change these prompts to be domain-specific, you need to implement your own fulfillment logic. Now, as part of our SDK for developing actions, we provide a Node.js client library that makes it really easy to do that. The client library API lets you specify the no input prompts like these. I didn't hear a number. You're still there. What's your guess?
And the conversation automatically ends after that third final prompt. So for example, we can stop here. Let's play again soon. That's how we're ending it. Now, let's look at the biggest opportunity for creative error handling: no matches.
So just like with no inputs, deciding whether you use the default fallback for your no matches or something more targeted should be based on the kind of interactions you're designing for.
Again, you need to consider if the answer is even needed. And if it is, you have to consider the user's situation and even the sequence of questions. And if you don't need it, that's where you also might decide to just move on, pivot, or gracefully end.
So that seems like a lot to consider. So where do we start?
So during any conversation, it's important to stop and look at what's happening in each turn. So usually, in one turn in a dialogue, one participant is usually the owner of the information that the other person is seeking. So depending on the context of the question and which side of the conversation has that information, the strategy will vary. So let me show you 3 examples of why this matters. In this question, the app knows the answer, and the user is guessing. But they do have a good mental model of what's expected, so potential errors are at a pretty low cost. If they don't know or they need help, they're likely it's just that they don't know how the game is played, or maybe they want to know how many guesses they have, or like we said earlier, maybe they just want to give up and have you tell them. But take this question for a reservation exchange. Here, only the user knows the actual answer. But you can make some logic assumptions, like expecting a certain range. And most of the time, the answer will probably be something like 20 or fewer people. So if the user needs help or says, I don't know, then the strategy you can use depends, again, on how critical that answer is to continue to the next step. So take a third example, where both sides are trying to match on shared knowledge. Well, both sides are supposed to know the answer anyway. But especially in this type of scenario where it's likely some sort of gatekeeping mechanism, the user may or may not know what it is, or they want to know, why do you need this information? Why are you even asking me this? And so for those types of situations, they're much more likely to need in-context help to continue.
So a good strategy here is to consider it context by context and offer up what might be more useful in that moment.
Exactly. So whatever is most likely to keep the conversation moving forward is what you would use to decide on how to reprompt.
So how do we decide on the wording?
I'm glad you asked, Leon. Well, first of all, there's nothing wrong with having a few generic fallback messages. So we call these rapid reprompts. Users often just need some sort of quick signal to indicate that you didn't pick up exactly what they said the first time. However, this strategy only works if you were listening for the right things to begin with. So if you aren't catching what they said the first time and you don't catch it even when they repeat themselves, you can imagine how that gets pretty tiresome pretty quickly.
So you need to consider the user's situational context for each and every question carefully.
Of course. So it often means asking maybe another way. Sometimes it even means breaking down the question into parts. Maybe even you're listening for both, but you might just ask for one just to move the conversation forward. Now, depending on how important, again, the information is that you're asking for, you can also make use of escalating detail to let users in on what is it you need from them and why are you asking. Again, to keep the conversation moving and answer that unasked question. And finally, depending on your app's persona and how assertive it is, you may also decide to be proactive and take control of the situation.
So let's look at how you go about implementing some of these more robust strategies. First of all, it'll require implementing fulfillment for the default fallback intent. Now, the fulfillment logic will then create these responses dynamically in code.
The core implementation strategy we recommend is to track user progress, lay out your reprompts, and like they say, when you love something, you got to know when to let it go. So for the apps that we've built together, our code logic uses counters and various session variables to keep track of the user's progress.
For example, here's the fulfillment logic for number Genie, where we use a counter to track how many times the user provided a response that was handled by the default fallback intent. Now, our client library for the fulfillment logic provides a way to store data within a user session.
You'll then use those counters to build a dynamic reprompt strategy, using both a combination of generic fallbacks sometimes and context-sensitive approaches like we talked about earlier.
Now, in API AI, the default fallback intent can be a starting point with a minimum set of basic reprompts. Here we have a set of default rapid reprompts that just provide a catch-all anywhere and will reprompt the user to say their response again.
From there, you can change those defaults to suit your app. So you might just want to add more to that list and add a few different rapid reprompts.
The agent will then randomly select from your prompts whenever a no-match event is triggered.
But like we said, sometimes you might want to pivot and ask the question a little differently, though. So a rapid reprompt might not be enough.
So in this instance, for example, we created a game, and we wanted to use the default handler to ask a yes/no question, whether the user was done playing. It's still generic and catch-all, but we've customized it to fit the strategy of our game.
But to get users back on track, you actually might want your reprompt to not be generic. So you want to reprompt with a little more context, like some of those examples we showed you.
So to plan for the logic needed to implement the context-sensitive reprompts, it really helps to see them mapped out ahead of time in some user journeys and sample dialogues first. For example, when I walked through the journeys Nandini wrote for number Genie, they drove what variables and states needed to be tracked in the app fulfillment logic.
And each time you reprompt, look for opportunities to add some variability or reframe the question. So this will lend more naturalness to the dialogue and help users sometimes not even realize they're experiencing an error per se.
So to reframe the question you asked, we can use a feature in API AI that allows you to tag intents with labels called context. Here's one that is tagged with the get time context.
And this is the fulfillment logic with the default fallback intent for the get time context and what it looks like.
So these can also be statically assigned in API AI's web GUI for each intent. For example, here's a list of intents we designed for a trivia game. Notice all the expected user responses we handle using many different intents, including help, quit, and restart.
Now, let's say you wanted to combine both strategies. We can show you how to implement both together in a more escalating reprompt strategy.
Now, from experience, we know that rapid reprompts work. But we also know, depending on the user scenario, we might want to pivot after another error.
So to do that, you'll need to keep a counter and increase it every time that the user response is handled by that fallback intent.
So here's the fulfillment logic for the default fallback intent for our trivia game. Notice how we use a counter value stored in the session data.
For the first time the intent is invoked, we provide a rapid reprompt by using the client library ask function. And for the second time, we respond with a fallback response.
Now, obviously, that escalation shouldn't go on forever.
When it comes to no matches, know when to give up.
Now, after you've tried a couple of times, once the counter goes above a threshold, bow out of the conversation gracefully.
Now, how you word that again is precisely depends on your persona.
So back to the trivia game default fallback intent handler. When the user response triggers the intent for the third time, we provide a fallback prompt and then end the conversation by using the client library tell function.
However, of course, if the conversation with the user recovers and another intent is invoked, like we talked about earlier, if they actually answer the question, then it's not a default fallback intent. Then we reset that counter value.
Now, those were just the basics.
Just the basics.
Yep. So from here, you can find lots of ways to step up your conversation repair game even more.
I feel like, yeah, but wait, there's more. So one way is to inherently disguise errors. So by adding naturalness and variability to make the entire conversation feel more engaging. So the key is that it doesn't just apply to your error prompts, but all the other prompts everywhere else.
So this is one of the many ways that designing with a particular persona in mind for your app comes in really handy.
So we keep hinting at this persona, so I'll show you one example of what we mean. So for example, in the trivia game we've been working on, we use a teacher persona. His name is Mr. Montgomery, he would be the type of character that is super encouraging, and he really wants you got this. That's his, he's a teacher, right? So
to give you an idea, our teacher has over 50 ways of saying you got the answer right.
And over 30 ways to prop you up if you got it wrong. Also, again, this is stepping up your game. Use threading techniques. So in spoken dialogue between humans, elements of a conversation are woven together in a coherent thread. And that includes both context and the way the conversation evolves over time. So this type of threading, it helps us keep track of that conversational flow.
Now, you would have to write the prompts that thread work together well, but programmatically speaking, you need to support that flow in some underlying framework. And that'll use tracking, context, and counters, just like we've talked about before.
So to support variability in threading, you could build a robust list of prompts and randomize them.
And you can scale that to any number of prompts without changing the code.
If you can randomize 3, you can randomize 103.
Yep.
The prompts can also be concatenated to create a large number of permutations.
And you can add dynamic values by formatting the prompts with variables that are replaced at runtime.
And to prevent the user from hearing the same prompts in sequence, you could remember which prompts you played and avoid them when you're randomly picking next from the list.
You can also track the number of errors and in what sequence they occur.
Finally, after you've deployed your app, your error handling approach doesn't stop there. So you should check in with what your users are doing, and you can adjust your strategy if needed.
Now, API AI provides a training feature which allows you to track which user responses are not being matched by intents. Now, this feedback could be used to expand your support for the user queries. It can also give you hints on what new intents might need to be added to your app.
So, one powerful notion to remember is that users who are not encountering errors should feel the benefit of progressing through so that when an error is encountered, they don't feel derailed. So, also, it's proven that reminding them how far they've gotten or that they don't have far to go will help them get back on track. OK, that's enough strategies for now. Let's look at these in action.
OK. So we're going to show you a demo of Number Genie, which we designed and built together. And it's available as a sample on our site.
So we chose a number guessing game because we felt like you guys, as developers, you could mentally map a number guessing game, and you can sort of picture some of the concepts we've been talking about. So we built in a hidden developer mode. This game is public. You're welcome to try this out. And I'm going to pray to the demo gods that they don't smite me here. But there's a hidden developer mode in which we can set the number that the Genie is thinking of, and we're going to guess around it so that you can hear some of the strategies that we talked about. Ready? OK. Hey, Google. Let's talk to Number Genie about 21.
Sure, here's Number Genie.
Welcome back to Number Genie. I'm thinking of a number from 0 to 100. What's your first guess?
50.
It's lower than 50. Have another guess?
0.
I see what you did there. But no, it's higher than 0.
30.
I didn't hear a number.
30.
You're getting warm. It's lower than 30. Have another guess?
17.
It's so close, but not quite.
19.
It's higher than 19. What's your next guess?
20.
Are you done playing Number Genie?
No.
Great. What's your next guess?
21.
Well done. It is indeed 21. Wanna play again?
No, thanks.
OK. So now, it's really interesting to see the interaction, but a number guessing game is deceptively simple. If you just think about it as comparing a number and a guess. But it can be designed to be delightful by adding layers of tracking in the game logic.
So let's look real quick under the hood at the fulfillment logic of Number Genie.
Now, we track a lot of things in the conversation. Notice that we use a counter for fallbacks.
We also track the number of guesses, the value of the previous guess, and how many times the user gives the same answer.
Now, we also consider how far away the user guesses from the answer.
As the user gets closer to the answer, in which the demo didn't work, we provide rapid reprompts and encouraging sounds. So try it out yourself, and you'll see there's a few hidden gems in there and the way it reprompts, and it throws in a few sounds when you're getting a little close or a little far away.
Now, we also remember if we gave the user a hint in what direction the answer is.
And we change the prompts and track when the user followed or ignored our hints. Be sure and try that out, too.
Now, here you can see some of the prompts we use in the game. We dynamically provide values for the variable characters in the prompts based on the user input and the game state.
So I hope we've shown you a foundation of building your conversation repair strategy. We talked a little bit about the types of error events to plan for, how to use built-ins and other existing tool features to implement in your design, and prevent the bulk of errors by anticipating and tracking user progress and context.
But the key to any strategy for creating a conversational experience, especially for when things go wrong, is to step back and look at the user's situation.
Don't create dead ends when something didn't work. So remember, it doesn't have to be treated as an error.
Now, there are more docs and resources available on our site, including white papers and a design checklist,
which includes an entire list of conversation repair check items. Also, take a look at the sample apps that we have open sourced in GitHub.
There's also a lot more talks about conversation design tomorrow, as well as office hours, so you can talk to some of our teams. And because we think some of the best strategies will come from you, we want to hear all about what you come up with.
So as you saw yesterday, we announced the Actions on Google Developer Challenge. We had a little part in that. Remember that when you're creating yours, that any winning app probably will have a killer conversation repair strategy at its core, right?
And we can't wait to see what you create.
Thank you.
Thanks.